Not sure that I see anybody in here. I just don't want to start until I get a few people in here. So if you are in here, can you just leave something in the chat? As I show 5 up on there, but I do not see any people listed. Awesome, thank you. Okay, great to know that we've got a couple people in here. I'm going to go ahead and get started and just tell you a little bit about myself and then what we're going to do today. And you should be seeing my TI Inspire screen for right now, and then I'm going to show a couple more. So I'm Beth Smith. I'm your education and technology consultant with Texas Instruments, and I have Georgia and Florida and a few other states, and taught math for 25 years and just love being in education. And what we're going to really go over today is how easy it is to code using the TI Inspire, whether it's a handheld or whether it's computer software, and what this could actually look like in a virtual world as well, if your students are still a little bit hybrid or even going into the future. And so there were a couple of things that you guys were supposed to download. And I'm going to go ahead and put this in the chat box in case you were able to not download the TI Inspire software. And this will give you a 90-day trial version. I'm always happy to give you a code that'll last forever if that's something that you're interested in. And then the other thing I need to do is to go ahead and send you the file that we're going to be using today. And so let me just send that to you guys as well. And then I'm going to download that as well. So that should be in there. And then I think to make life easier, when I go to sharing, I'm going to stop sharing for a minute so then I can just share my desktop with you guys. And I am not sure why I'm having trouble sharing this desktop again. There we go. Okay, awesome. Okay, so can y'all put in the chat box if you were able to download the software before we got started, whether that's a yes or a no. Okay, so do y'all want to take a second and try to download? And then just let me know when you've done that. And then I'm going to go ahead and show you guys as you get that downloaded, because that's going to take just a little bit of time. I was trying to put that file. There we go. And there. And I'm going to go ahead and also send you a Google link in that chat box that has all the information in that as well. So it'll take us just a minute to get going. And so that's a link to a Google Drive that has everything that we're going to go ahead and talk about. And I need to go ahead and dump that. Did y'all get a file with an extension of TNS in the chat box? Because I do not see it coming through on my end. Let me see if I can copy. There we go. Okay, that's what you needed. So I think you guys should have everything that you need. All right, so let's get this ball rolling. What I want to do is, before we get into coding, which we should be getting into in just a couple minutes, as far as what Texas Instruments has to offer in the realm of coding, and we have basically, you can code on both the TI-84 CE platforms and also the TI Inspire. We're going to be using the TI Inspire today because we now have Python as an option on this, which is awesome, because I just think for, you always say if you can code it, then you know it. And so what would this look like, whether it's in a math classroom, whether it's in a science classroom, computer science, STEM, you've got like a lot of options. And so we're going to be using the TI Inspire platform right here. Okay. And with that, we can code in TI Basic or TI Python. I'm going to talk about TI Python today. And you can see on the screen right here that we have what we call a TI Innovator Hub. So this is our version of the, it's our microcontroller. So if you guys have heard of like a Raspberry Pi or Arduino, that's our version with this. And then we also have the TI Rover that basically you can place the code and then you're going to be driving the Rover with the program on the handheld. All righty. And we're going to be doing it on what we call a virtual Rover, but know that we can do that face-to-face as well. What do we have? We have a lot of different STEM projects for both the 84 and the Inspire platforms. And the lesson that we're actually going to look at today, if you were doing it in your classroom, you would basically have your students trying to program the rover to draw around the Mars map, if you will. So we have that. We have lots of different STEM projects, such as we have one for just the mood ring. And if you look and see really what all that is tied into, you can look right here, is that they're going to learn science, the color inequalities. I love just the whole concept. How do you mix the values from 0 to 255 to make different colors? So they're really dealing with parts and ratios. And then with coding, they're learning about loops, conditional statements, and that not. And again, these are on the link within that Google Doc. We also have just amazing professional development, and a lot of that is free as well. We have a lot of webinars, and if you're interested in learning about Python particularly, last night was our first, let me go, I think I went to the ones that are recorded. All of these are recorded. Last night was the first one on a series of 3 weeks with coding with the TI Inspire Python. And so that's going to was last week. And then we've also got one in May and then one in June. So lots and lots of opportunities for that. All right. Okay. So comments, have you all been able to download the software? And if not, we can still do this together. No big deal whatsoever. If y'all can put that in the chat box, that'd be great. So y'all still downloading or, okay, working on it. Awesome. Okay, so with your Mac, that's a big issue. It'll actually run it because I'm on a Mac as well. I think you have to right click it and say trust anyway. All right. Okay, so that you could not open the TNS file. Okay, so if you'll go to that Google site real quick, I'll go ahead and make sure that TNS file is in there, and that may be a way to open it. And if not, that's okay, because we can, y'all can still have some input with what's going on for the next little bit. So let me go ahead and make sure that is there. Okay, so it should be on this site. Okay. And again, I put that link in the box. Okay, so let's go ahead and get going. And then we're going to start coding in a little bit. So you'll still have time to really download that and open it. I think that this is one of my favorite quotes of all time, just be in an education. And tell me I forget, teach me I may remember, but involve me and I learn. And that's what I love just about the whole concept of really embedding coding in the math classroom or the science classroom. And it was actually in one of the sessions earlier this morning, they were making a comment that if you don't know something, just ask your students. And so I think we can learn so much from our students. And I think that failure to me is just an opportunity for success. And so errors are great things because that's where we grow in many different respects. So what is really Python programming? And some of you guys that are here may have a lot more experience with this than I do, because I'm really just still learning a lot about this. But on the CX2, I mean, it's really quick. It's really easy. Python in general is procedural and object-oriented. It's been around for a really, really long time, and definitely is one of those really being used a lot now in a lot of different areas of life and industry. And with the Inspire CX2, what I like about it is you guys are going to see within the next 5 or 10 minutes how easy it is to code without any experience whatsoever. And so I have one program here that's already written, and we're going to run it. But if you look at what is with the TI Inspire, our programming is menu driven. And so both the TI Basic and the Python. And so it's great after that drag and drop that you may use with like Scratch or some of those other programs. So you can go ahead and type in the codes, but we know with coding, when you're typing in codes versus pulling from a menu, there's so much room for error. And when you're on the Python, this is what we call an editor page. So this is where you're going to basically code your program and put your code in. And up here, what I've done is just imported an image, and you can see some of the coding. And then to run this program that's already written, I'm just going to press Control-R. And this was just basically a program that said, hey, import this image and let's position it on the screen and let's put some words with it. And if I press Escape, you can see that we have a Python shell here. So there's really two apps on the Inspire, the editor and the Python shell. And so in some respects, you can say your program runs on the Python shell unless you have something that's going to be a little bit more robust. And what's interesting about the Python shell is I'm still learning about this, but it really operates similar to a calculator page. So you can actually do a little bit of coding on this page. So if I just put 3 + 4, we're going to get 7, and it would act like a calculator page in that respect. All right, so let's go ahead and move on to this next page. And what we're going to do is we're going to program the virtual rover to draw around a path. But before we get to writing a program, I really wanted you guys to look at to this program. And what we've done is we have imported some modules up here. And so if you go back and look at our menu, we have some built-in modules that I think are pretty much standard with all Python coding. And then we also have some other modules that we've added. And the modules that start with the TI are basically just for the TI Inspire. And so my understanding of modules is basically it's just a group of a lot of code that you would want to use over and over and over again, but you don't want to take the time to always go and write it. And so what this does is it's basically importing that simulation rover, since we don't have the rover itself with the calculator on it. And what we have the ability to do is say, okay, you can put a pin in the rover to have it draw, but right now there's no pin. And then it just shows that we're going to move it to the coordinate plane 1.1. We're going to put the pin down. And I'm going to go ahead and run it, and then we could talk about what it actually did. And so any success with loading the software yet? So if we look at what this did, you could see the rover. It just did a point. It did a segment. It did a triangle. It did a square. And imagine having the students program the rover to draw a square and then a triangle and then a pentagon. So when we're in geometry, we're not putting up a formula on the board, but they're investigating it and they're understanding that the sum of the exterior angles is 360. Or how do you figure out what the measure of interior angle is of a regular polygon? So lots of good options right there. Okay. All right, questions so far? All right, no worries on the downloading as long as we're getting it going. But you can see like what you could basically do in the classroom with this. So you guys are going to help me out because we're going to go ahead and get some coding done. Now, once I run this program, I can press escape and you see it puts me back on that Python shell. When we have a TI Inspire program, file open, you can see that we just can toggle through the pages. We can press the arrow key to go through them, or we can press the control left arrow here and back and forth. Have any of you guys ever used the Inspire? Do y'all use that in your classroom at all? Or do you use the 84 or any graphing calculators? All right, so our whole concept with really the Inspire and the 84 is it's a one handheld device that basically can go everywhere with the kids, whether it's math, whether it's science, whether it's coding, whether you're taking your state test or ACT, SAT, IB, AP. It's just one piece of, that they can carry with them that you don't have to worry about the internet. That being said, we do have software and whatnot. So what we're basically going to do is we're going to have two challenge. So we want to program the rover. The first challenge we're going to do is we're going to program this rover to basically drive to the blue dots. So to these three blue dots, and then to the green dot, and then back to the red dot. Okay? So if you guys can just take some time and figure out how you would estimate these points on the coordinate plane, and write down in the chat box what you think the 5 ordered pairs would be. So at least I can gauge you a little bit here. And so what do we think this blue point right here would be if we had to estimate it? But go ahead and type in what y'all think the 3 blue points are. Whoops, sorry about that. Okay, so hold up. I saw that. Let me see if I can get this a little bit bigger for you guys. Eric, are you with all 3? Are you I'm trying to think. I know someone said there were a few people. Okay, Stuart. Okay, if you guys are still there, can anybody see these? All right. Yep. Okay. So one would be 0.55. You can try that one. What about another one? And I may have lost a few people with, okay, or we could say 0.5. All right. And what about the second blue one right here? So if we look at that, maybe 1, 2, 3, 4.25. Okay, I love it. 4.25, 2.67. All right, and what about our last blue dot down there? So 5.9, negative 4.25. Okay, and the green one way over here. That looks like it's a pretty easy one. So maybe -8, -4. And then what about the red? So, all right, and let's look at the red one. That would be -7, yeah. And then 6, 7. Okay, so we're going to go ahead and program that. And so here's our editor. So this is where that we can basically adjust the program a little bit and add to it. So I've already done this for you guys. And so let's talk about what this lingo is. So we've imported that rover simulation because we're not using an actual rover. And we've done the simulation setup. And so those are basically, we have a phenomenal, one of our instructors is just amazing. He's from Canada. And I will make sure I put the link to his website with what he's doing with Python on the Google Drive. And they're saying RV grid true means yes, we want the grid showing, and RV obstacles are true. And so basically those obstacles would be those points. And then the RV axis would also be true. Axes just say, hey, we want those axes showing. Okay, so somewhere in there, RV obstacles, I'm thinking that's probably somewhere in that simulation setup. And so we're going to put our coding down here at the bottom. And so to go ahead and we would go to menu. And we're working with the rover. So even if we're virtually using a rover or we have the physical rover, we would still go to menu, rover, and we want to drive the rover. And we just want to go to XY. Now, if you'll notice this, they've gone ahead and pasted that code. So again, the students wouldn't have to worry about a lot of syntax error with, where do you put a decimal point? Where do you put a comma? And it shows up where it's blue highlighted. So it's like, okay, that's in like a light gray. I'm expecting you to put something there. And I think we said the first one was 0.5. And then to go from wherever you need to enter something to anywhere else, we would use the tab key. And then just like all coding, a different command has to start on a different line. And so right now our cursor's inside the parentheses and we need to move outside the parentheses and press enter. All right. And then we would want to put our second point in. So again, we would go to menu. And then we could go to TI rover, drive rover. And I want to pause here for a little bit because I don't know how much we're going to get into this. But you can see where you can do forward, backwards, you can do angle terms, you can stop, you can resume. My favorite activity to do in the math and science classroom with the rovers, and I haven't figured out how to do this yet on Python, is the distance, rate, and time activity, where you're basically having the rovers drive along the horizontal line, but what does that look like graphically? And the number line is like, are they going forward? Are they going backwards? How fast is it traveling? Is it stopping? And for kids to understand the whole concept of even when that rover stopping time is still going on. So what does that horizontal really mean as far as a rate of change? And to connect the math and science together with your speed and your velocity, it's awesome. And these are the kind of commands we would use for that. And so 2xy, and again, the next point is going to be 4.25, tab, 2.67, and I'm going to move out and press enter. And so some of you are going to ask, could you go back and copy that command? You certainly could. Can I type it? Now, if you're on the handheld, it's a lot easier to go to the menu versus typing. But notice when I type it, I have to be very careful because I don't have that gray XY. So I'm just going to have to know exactly that I need to be putting 5.9 times negative 4.25. Okay, so that would be one option. Could I copy it? So yes, just like on the computer, all the shortcut keys that are on the computer pretty much live in the Inspire as well. So I could highlight this. I can go Control C. I can come down here and go Control V. And then I can just use the backspace button. So again, lots of options, but with coding, this also, lends itself to, okay, we have to be careful of syntax errors. And so to do the last point, I would go Menu, GI Rover, Drive, 2xy, and then we would put in 6, 7. Now, the keyboard shortcut to run this program is Control R. But if we go to the menu and we go to Actions, not Actions. If I need to back out of a menu, I can just press the Escape key. Run, and then that's where check syntax and save, if you just want to do that. If you want to go to the shell, remember we talked about there's the editor page and then the shell page, or command, I'm on a Mac, so it's Command R instead of Control R. But if I just press run, let's see how well we did. We did pretty well. So how could we adjust these points? Let's look at our third blue point at the bottom. And this would be where there could be some great dynamics. Okay, what has to be adjusted? And it looks like, that maybe adjust the X value a little bit, or any comments about that. If y'all can put that in the chat, that'd be fine. And then we could adjust our red one too. So any ideas on maybe some new points there? Oh, yay, I'm glad it's almost downloaded, Eric. So let's go back. And so let me talk about how we would adjust it. And I think that third blue point we had at 5.9. So maybe let's try 5 and see what happens. And that red point, it looks like our X value needs to be increased. So maybe do 7 and decrease our Y. So maybe 7, 6. So once it's finished, I press Escape, and notice that it took me to the shell. So I had already been running this a little bit this morning just to make sure we were all in good shape. That's page 3.5. Our coding, our editor is right here. And so all we need to do is let's go back and make this 6,7, or 7,6, sorry. And then, what did we need to make this one? I think I saw a 5. And then Command R. There we go. So those look pretty good. Oh, wow. We nailed it, right? So again, what are some ways just using the coordinate plane in your classroom, or getting the rover to turn certain angles, that you could use this in your classroom to help students understand concepts? Any ideas? Yeah, in math or yeah, either one. I love the rover too, because I think unfortunately, self-driving cars, which is really scary, are going to be here sooner than later, and I think it helps students realize how important precision is, and something like that, and in math and things of that nature. I've always kind of used that example of, gosh, if you're an open heart surgeon, you need to really understand which direction you're going to go. Is it a half a centimeter to the right or to the left, and what could that be? So I think that that's really good. Now, the next part of this program, and I know that y'all are not really engaged as much as I wanted you to be, but I love angle rotation. And actually, when I do this with students, and pre-COVID, we could visit classrooms and things of that nature. I will say that we have a workshop loan program. So if this is something that you want to try before you decide to buy it, we have opportunities for all of that. But the whole concept of angle of rotation, and what does that really mean? So the next part of this would be, how do we go around the blue dots? And so let's just take this first one here. If we wanted to not crash that blue dot, we wouldn't want to be going to 0.55. Maybe we would want to go to 0.6. And then maybe we could just be easy and make like a 40-degree turn, right? Or not 40-degree, 90-degree turn. And so what would that look like? Yes, Johnny, I love your comment about the difference between 6 and 7 and 7 and 6. Exactly, yeah. So why don't we try that? So let's go to 0, what would that be? 0.6. And then let's turn 90 degrees. And we would have to go, let's look at some of those other commands that we had, that we could use there. So we know we have the RV to the XY, or we can go forward and backwards. Okay, so I'm going to do the first little thing, and then I'm going to let you guys kind of think about it. So we could go to 0.6, we could turn 90 degrees, 1 unit maybe to the right, and then go back to that point. So what would that look like? So this would be 0.6. We can come in here and just edit this. So menu, TI Rover, drive, and let's turn right. And it's saying, okay, you're turning right, I need a degree. And I don't know if y'all saw that little yellow piece pop up. No worries, Eric. We're just adjusting what we're working with. So it's going to make that right degree turn. Now I'm going to go ahead and do Control R, because I want y'all to see what this does. And so again, we can press Control R. Oh, okay, and see, I didn't even realize that it went ahead and did that 90-degree turn, and then went ahead and went to that next point. Now, what's interesting, if it went straight up, I want to run that again, because it seems like it went more than 90 degrees, or am I not looking at it right? So I think I'm going to put another command in there because I need to kind of understand what it basically said. It said 90 degrees, but then I need to go to that point. So I think what it did is turn 90 degrees, and then it didn't pause or anything. It just turned the 90 degrees and then went straight to that point, which is what it looked like. Yeah. Yes. Yeah. And what we're trying to do is to kind of get it to go around the blue so that we don't touch it. And so this was that whole Mars thing. I haven't figured out how to put that Mars back behind there. So basically the concept is like, we don't want to drive around we don't want to fall into a crater. All right. So let's play a little bit. And let's put this, now let's let it go 1 unit forward. TI Rover, drive forward. Now, notice the yellow sign that it was in grid units. I'm going to put 1. There we go. Okay. That's kind of what I wanted a little bit with. Do y'all see what I'm saying? That, you know, you want to get it to drive forward and then turn. And so students, I think they don't understand that whole angle of rotation. I think sometimes when we use too much technology sometimes where, you know, we don't bring out those protractors enough, you know, and so I love this because they get the whole concept of angles of rotation. And I think that's just important in math and science and driving. It's, you know, they start driving, like, what does it really mean to make a hard turn and what kind of angle is that? So lots and lots of good stuff right there. All right, so let's do, how can we adjust what we're doing to go around the second blue point, and then we'll stop there and I'll see if you guys have any questions. So ideas on how to get it to go around that second blue point. And then this is where you can put parameters in your kids. It's like, I want you to use these commands so many times, or it'll even measure the distance that it's driven. So you can say, okay, you know, I want you to do this in the least amount of turns or the shortest distance. So any ideas what we could do to adjust that? So let's say no turns. If we didn't want a turn, what could we do to get it to go around the blue point? What would we adjust? Could we maybe even adjust this point? And maybe make it 1, 2, 3, 4, 5, 3. So let's try that. Whoops, there we go. All right, and then Control R. Awesome. So lots of things with this. The one thing that I like about coding is, I will say, the first time I was able to go was up in Cobb County with a middle school teacher. And we had the Rovers programming them to just draw a path on a graph. And what was neat is that the students that struggled the most in the course were the first students to basically accomplish the goal of getting the rover to draw, to kind of follow the path, which to me, that was awesome because, you know, a lot of these students, maybe they learn differently or they need something to engage them. And, you know, it's like, once you got them, then you got them. And the flip side of that is, I think so many of our students memorize stuff And so the students that are like your memorizers struggle with coding a little bit. And I think it opens up so much for them as well, because we know math wise, at least you can get through maybe algebra 2, maybe pre-calc, and some kids even get to calculus by memorizing, but they won't be successful in calculus. And so I feel like just programming in the Rover and our STEM activities, like that's what I've seen when I've been in classrooms with teachers, as far as it just everybody's engaged. And I was in a school at Fulton County right before COVID, and one of the girls in there just had a bad attitude. I'm like, oh, okay, I'm gonna, by the end of the day, by the end of the period, she's gonna be having a good time. And it was Valentine's Day, so they accomplished what we did. They said, well, let's go draw a heart. And by the end of the class period, she did not want to leave. She had smiles on her face. And the bottom line is she felt successful. And to me, that's what it's why it's what we do, is how do we help our kids feel successful? How do we help them show them that they can lead a life of significance and learn? So any comments or questions? Were you guys able to get on that Google Drive, I think, correct? All right, and I put all my information on there. I'm sorry, I think we lost some of the people that that jumped on there with the group with that. I had trouble setting up my second screen a little bit ago. So, but just know that we are, as far as Texas Instruments, we are here for you guys. Like I mentioned, I'm always happy to give you software. I'm always happy to jump on a Zoom with you so that you can learn more. And we do have loaner programs. And the last thing that I will show you is a little bit more just about our activities. So with the TI Inspire, I don't know if I've got more math teachers or whatnot in here. We have tons and tons of different activities, and they're really designed to help students discover the mathematics. And so rather than us, tell them something or tell them the equation of a linear equation or parabola equation, they can discover it. And so you can just see some of these activities that you can tell by just looking at them, how engaging they can be on the Inspire. Domain and range, families of functions. I love geometry too. My favorite with geometry is transformational geometry, where basically students investigate and learn about the, I probably can open one of these. I don't have that right pulled up, but they can basically investigate the transformational geometry, where they see the big picture first and they're adjusting it. If you're a science folks, we have lots and lots of simulations for science. And you can tell again, just by looking at these images, that they work great with the Inspire. And so our whole concept is the tough to teach, tough to learn concepts, and what can we develop to help out with that. And all of our resources are free. Okay. But anyway, any other comments or questions? Okay, so I hope y'all have enjoyed this. I know that there was an issue with not having any software, but just again, I'm here. Reach out to me. I'll put my email in here real quick. And always available to chat. Okay. All right, y'all enjoy. I hope you enjoy the rest of the day. And you guys are most welcome.